Hey guys, it's Mr. Win, and this is the other part of your STAAR review for today. It's graphing exponential functions. So we're going to talk about what the graphs would look like, kind of predict what would happen, and interpret these graphs as the exponential functions. So some of you may have already watched the writing exponential functions. If you didn't, make sure you do watch both of these because they are both important, okay? It's how you're going to complete both of the assignments, all right? But these are exponential functions, so that means y equals a times b, x is in the exponent, right? Exponential function, x is in the exponent, okay? So if you look at the first example, y equals 0.52 to the x, that means a would be the first number, 0.5, your initial value, b would be 2, your ratio, okay? So the y-intercept, if you check this, all right, the first graph here is shown in purple, all right? So right here, it's in purple, okay? Notice that the y is 0.5 and 2 to the x, so that means the y-intercept is always when x is 0. But if x is 0, that means the 2 would be to a 1. So your first number, your initial value is always your y-intercept. It's your initial value. It's what you start with. It'd be 0.5, okay? And all of these graphs do have a horizontal asymptote. Okay, notice even in the picture that all three graphs has an imaginary line that it doesn't cross of 0. Okay, one of those things. These graphs don't cross 0, so your horizontal asymptote is always when y is equal to 0. Okay, so let's look at the next one. 2 to the x. Well, hey, there's 2 in parentheses. We know that's our b, but what would a be? It's missing. In this case, it would be 1. So your y-intercept would be 1. You would start at 1, and your horizontal asymptote is 0. So if you look at the graph y equals 2x, this red one here, yeah, see? It starts at 1, okay? If you check 2, all right, so 2 is a, then your factor is 2, so your y-intercept is now 2. So do you see how if we increase the initial value, your y-intercept is changing, all right? So that means your horizontal asymptote is still the same, but hey, look at this. Your y-intercept is now 2. It's just your initial value. We went from 0.5 to 1 to 2, and you might be able to guess. But if I put a 3 in the front where a is 3 and b is 2, your y-intercept is now 3. And if I put 3 on the graph, hey, look, it's increasing. All right, horizontal asymptote equals y equals 0. Okay, so the bigger number your initial value, the bigger your y-intercept will be. So if you wanted to predict what 0.75 times 2 to the x, well, it'd probably be here where we start at 0.5. Okay, so somewhere in between 0.5, and it should look something like that. Okay, that was an awful line graph there, but shown there. Okay, that's what 0.75 to x would look like. All right, well, look at these graphs. What if I'm changing the ratio, okay, changing the b value? So here, there's no a, so a is 1, but b is going to be 0.25. Notice the graph here, 2.5, 0.2 would be, I guess not on the graph. So that means the y-intercept is still 1, intercept is always 0. Right here, if I have a y-intercept 1, but I change it to 4, okay. So I guess this example was supposed to be 2. That makes more sense. 2 to the x, the green graph. Notice how wide it gets, okay? That's your graph there. Notice how wide it gets. And then if I look at 4, okay, notice how it's going. Oops. Okay, it's kind of going more in now, right? So that's y to the 4. Your y-intercept is still 1. Your y-intercept, your horizontal asymptote is still 0, okay? And then look at 8, okay? That function 8. I don't have an orange color here. 8 here. It gets even closer, right? So 8. Think of it as saying how you're multiplying by 8. So it's moving, it's increasing by 8. It's going up faster. So notice how if you change b, okay, from 2 to 4 to 8, right? It's getting closer and closer to the y line. It's kind of going up faster, okay? What if there were fractions, all right? fractions make these exponential functions decrease. So they're inverse, right? Or no, they're going the other way. They're going down, right? Notice that curve. So if it's 0.25, that means we're decreasing, okay? But we're decreasing at 0.25. If you look at the graph, it's the red one here, okay? 0.25. Notice how it's still a little out, but not as slow, okay? It's decreasing pretty fast. Say it's decreasing actually by 75%, but 0.25, you're multiplying by a small number and slower, okay? If it's a little higher decimal, like 0.5, notice how the graph is going slower. And 0.75, decreasing slower as well, okay? So that changes how it is. Like the smaller the fraction, right, closer to 0, the faster it's actually decreasing, okay? So here, we still know that A is 1. If B is 0.25, at y-intercept is still 1, and horizontal asymptote is still 0. A is still 0.5, B is going to be, A is still 1, I mean. B is going to be 0.5, your horizontal asymptote is still 1. Your vertical y-intercept is still 1, your horizontal asymptote is still y equals 0. Sorry. And then here A is still 0.75. I am messing up all over the place. A is still 1. B is still 0.75. So your y-intercept is still 1. And then your horizontal asymptote is still y equals 0. There we go. Okay? So if you wanted to predict the graph of 0.2 to the x and 0.5 and 5 to the x, will they be similar? How will they be different? Well, 0.2, remember, they're a fraction decimal, so we know it's going to be one of these, right? Closer to the 0.25. We know it's going to be decreasing, okay? So this is decreasing. 5 to the x will be increasing, okay? But remember, the smaller the decimal, like 0.2, 0.1, 0.001, the smaller it is, the kind of steeper it gets, right? It kind of goes steeper like that, right? But then if it's above 1, if it's increasing, like a 5, the bigger that number is, it's increasing quickly as well, okay? So the way they're similar is that they're both kind of increasing or decreasing fast, okay? Both pretty fast, closer to the y-axis. Just to kind of picture, right? It's going up faster. They're kind of closer to that y line. Here's the y line down the middle, okay? So that's one way to think of it, all right? Let's interpret these graphs. The graph below shows the annual salary for an office worker, okay? So here's our graph. Office worker, this is his salary. This is the number of increases, okay? So the number of increases, this looks like it's going up exponentially. All right, let's see. Based on the information on the graph, which of the following conclusions appear to be true? Check all that are true. Okay, so the office worker's salary doubled every 4 years. Now, did that happen? Let's see. Your initial value, you know, is 5,000. Okay, so we know it starts at 5,000. What happens if I go to 4 years later? Here's 4. Did it double? Well, it went to 10,000. Yeah, it doubled to 10,000, right? Let's check another 4 years just in case. 8. 4 plus 4 is 8. 20,000. So 10 to 20,000. It also doubled. And you can assume it keeps going like that. So here, yeah, it works out. The office worker's salary increased about 5,000 every 4 years. Well, we know it's doubling at every 4 years. Okay, maybe the first time it went up 5,000 from 5,000 to 10,000, but the next time it went up 10,000, right? So it's not really about 5,000. Maybe the first time. See, this increase here, from here to here went 5,000, yeah, but here to here was 10,000, so that's not right. Okay, so that we're not gonna cross that. We're not gonna check that. Let me draw those points again so we see. Let's read the next one. The office worker's starting salary, that sounds right. Starting salary was 5,000. Yeah, A, your initial value was 5,000. That's right. Okay. The office worker's salary increased about 10,000 between the years in 4 and 8. So now we're being specific. So the officer's salary increased about 10,000 between 4 to 8. So if I went from 4 to 8, right, from here to here, all right? We can ignore this, right? Did it increase about 10,000? Well, I went from 10,000 to 20,000, right? Yeah, it increased by 10,000. We can check that off. All right, next one, the office worker's salary increased more between years 1 and 2 than between 9 and 10. Well, between 1 and 2, okay? From here to here, right? Remember, we went from 5,000 to 10,000, okay? That over 4 years was 5,000. And then the next 4 years, it increased 10,000. So the next 4 years and so on, you can assume that it's going to be more, right? So the years of 9 to 10 should be increasing more, okay? Because you had more, it's doubling, it's increasing more, right? So 1 to 2 is definitely not more than 9 and 10, okay? So the officer's salary increased more, 1 to 2 to 9 to 10, that's wrong. It'd be the other way around. It makes sense to increase more here from 9 to 10 than from 1 to 2. Even look how, okay, you can even section this off. Look how steep that is. And look how, okay, low that is, right? So we know 9 and 10 is definitely more, okay? So that's not it. So the officer's worker's salary increased more between 9 and 10, so flip that around. Yes, that would be right. 9 and 10 more than 1 and 2. All right, that's it. Sure, that's interpreting that graph. All right, let's look at another one. What if I can make a table here? Okay, sometimes when looking at this, it might help to make a table. So at 0, the number of increases, right? You had 0, your salary was 5,000, okay? At 4 up here, remember, was 10,000. At 8 was 20,000. And you can assume from here, right, it's going to keep doubling, right? So 20,000 doubles would be 40,000. Double that times 2, 80,000. Okay? So the estimate the worker's salary after 20 annual increases would be about 80,000. All right? So again, you can use the, write out a table if you have to. You can use your calculator, your Inspires to put in a table as well. It can tell you regression if you want an equation and even plug in X, right? It's something we did on the writing equations one. But yeah, so a couple ways to work through that, right? And that is it about interpreting a graph. Hopefully you guys can go ahead and finish. That's enough for you guys to finish the rest of the problems, finish those STAAR problems. Again, there are released questions from the last STAAR. They look very similar. Try to understand these, okay? If you have a question, let me know. But try hard to understand these, all right? That's it.